Hello, and today we'll talk about linear regression. Just as a little disclaimer, I'm not professional in this topic. I'm also a student, and if you're looking for professional explanation, um, it's not the case. And here I am trying to. I found this way of recording such videos helpful to deepen my understanding. So if you would like to um, hear and see the way how I understood the topic, welcome. Otherwise, you can find other videos on YouTube about this. And previously, I recorded videos about metrics, about quality functional, loss function, and we learned about what's included within our data set, such things as objects, target, value, features, samples, and so on. So we don't know this stuff, how to find, and we are ready to build to understand how our first model works. And we will try to make a linear regression model today to understand how it works, to be correct. So basically, we will have simple data set. Suppose we have just one feature for simplicity and one target, and we have two objects with three with three value of the first feature and the 6 as a target and 9 and 8 for the second object. So basically on the graph it will look like this. 2 points represent two objects from our data set. We can actually place as many points as we like, depending on our data set. It might be thousands of points, maybe 10,000, 100,000, as many as we like, as we have for a particular task. And once we have enough points on our graph, we can see that they are distributed uh, in a particular way, and we in this case where we have just one feature, d1, and we can simply visualize this on the two-dimensional graph. And we can visually see and plot particular line that we think can describe our data, how our features describes our y target values in the best possible way. And in this case, it will be this particular line can do that in the best possible way. So basically, we just have built a model. But what doesn't building a model mean? Building a model means establishing the best connection between the features D and responses target values Y. And the function will look like this. Our prediction Y hat and beta coefficient 1 multiplied by D1, our feature. So B1 will be model parameter here, and in machine learning, this usually is called weight of feature D1. By substituting different values of B1, beta 1, we get different straight lines. So basically, our general form is the same, but instead of B1, we can substitute it with different numbers like 0 0.5, 2, or 1, and we can get an entire family of linear models by changing B1. They all have the same structure but different slope. And we can see that the higher slope, the B1 we have, and then the higher slope we have, the steeper of our function looks like. For example, 0 0.5 slope is much shallow. here, and the purple one has slope equals to 1, and just normal one between these two. So key idea is that one simple formula gives us an entire family of models, and we are free to pick the best one that fit into our data. But there's another problem that it's not just enough to find B1 to find the best possible line that describes our data even in two-dimensional uh, space, because we can play as much as we like with our slope. Still, our data might be a bit higher or a bit lower than in general. So we need another way or another adjustment of our model to be more accurate. And for that reason, in machine learning, we use another important coefficient. It's very popular and used in many different models. That is called bias-free coefficient, or another name is intercept, that is used in scikit-learn library. So if we add our coefficient, bias or intercept, we can play a more accurate. We can uh, we can place our model to be a bit higher on the graph. We vertically up it, or we can down it if we think that we need that particular operation. Mm, So we can place it a bit higher or a bit lower without changing our slope. It's very useful, and basically it's the same as adding to our predictions constant number. To all of our predictions, we just add a bit of constant number to a bit fine tune our model to the right place. So basically, we just learned what is a linear model. And linear model is a family of algorithms that are built on one simple principle. And that principle is take all the features of an object, multiply each by its own coefficient or weight, and sum the result. And that result will be our prediction. And we can have as much coefficients, our features as we like, depending on our particular data set, particular business task, and so on. Each of these beta coefficient will has its own unique value that is relevant to this particular task to find the best explanation of our data set of our target values dependent on our features. It may seem to be that it's enough to use a visual way of trying to fit our line in the particular place to find best slope, best free coefficient to describe our dataset as a straight line, but we we don't always have just one feature, and it's not always a two-dimensional plane, two-dimensional space. Yes, in our case, it's might look easier just to find a straight line by playing visually, by looking and finding best b1 and b0. But there are other cases. For example, we might have two features like x1 and x2, and in this case, our model won't be just straight line; it will be plane in the three-dimensional space with the three coordinates x1, x2, and y. And our function will look like this to find our prediction. We will add additional beta 2 and x2. And it's not just two features and not just three-dimensional space. We can have multiple features and n-dimensional spaces. In this case, our model defines not just a plane, but a hyperplane. It's a name that generalizes plane to a higher number of dimensions. So, as a summary, we learned which models are called linear and found those rules uh, that describes an entire family of models. We obtained specific algorithms that need to tune the model's parameters, how we can tune models parameters by playing with the beta coefficients, and always learned that we always have to add constant bias feature for our linear models to be more tuned to our data. All right, tried my best to explain this. I'm sorry if my English wasn't good or the way how I explain. It's not clear enough. Try my best, and thank you if you are still here. Wish you good luck in your journey of learning machine learning. Thank you.